Hello and welcome to our second PAT-Forum of this year. My name is Marilena Pagano and I am the application specialist at Hellma. Today I would like to welcome you to our webinar with PAT specialist Dusko Kadijevic on the topic Take it to the next level with PAT and spectroscopy, how to realize successful projects that inspire. Today's expert is Dusko Kadijevic. He has over 17 years of professional experience and is a recognized PAT specialist with a demonstrated history in the chemical industry. Currently, he is the laboratory manager at Menzel Metallchemie GmbH, where he oversees quality assurance and the development of biodegradable high-performance oils for minimum quantity cooling and lubrication technology. After graduating in chemistry from the University of Reutlingen in 2006, he joined the BASF, initially as a team leader for process analytics and later as an automation engineering business unit as senior automation engineer, where he managed global PAT projects. I'm glad he found the time to share his experience with us today. Welcome, Dusko. The stage is yours.
Thank you, Marilena, for the introduction, and hello to the audience. It takes a lot of pressure of me because we have such experienced people here. I'm pleased to be here and see at the Hellma Forum, and it's a great opportunity to exchange knowledge with the PAT community. Today I will talk about projects or PAT projects. First of all, you see here the agenda. After my introduction and my general perspective on PAT projects, I will also present two practical examples. This will give you a small insight into the paths and detours of a PAT project. What is a PAT project? Primarily, it involves the introduction and the installation of an analytical measurement in a process, of course. It begins with the determination of the goals of the measurement. What should be achieved? This point should not be underestimated. This is very important. Often a common understanding of what needs to be achieved must be first established. What I mean, is the measurement just for monitoring a system or process, or you want to controlling the system or the process, or it is a approach to autonomous operation of the system, means no operator involved in the system. Here we have some points like critical process parameters and critical quality attributes and critical material attributes are very important points to be clear in the beginning of the process. And choosing, of course, the right partners for the project implementation is crucial. I will go into more details on the next slides to this topic. Why a PAT project is important. Here I want to highlight some essential points. Energy saving, raw material saving, environmental protection, and quality are significant impact on the production. The cost pressure is immense right now and increases also the desire to more efficiency. So PAT is a good solution for that. And don't forget, the demographic change is also a driving factor for advanced automation. The data shows without automation, we have some challenges to maintain the production and also our living standards. So PAT is the solution for this kind of stuff. Why is it necessary to have a PAT expert in the house? Today, PAT, it's about much more than just adding a sensor in the process. It means automated processes or production in a larger scale. Every company and every process are different. And even if in a single company like BASF, there are many different ways to operation and organizations. It's hard to imagine. We have really different partners. You have to be agile and to adapt to the circumstances to achieve a good result. So therefore, it is important to have somebody who keeps an overview on this, brings all the different parts or partners together. I'm talking about real-time process control and setting the right tools in the given environment or organization. One colleague said to me, if you only know the hammer as a tool, everybody looks like a nail. A PAT expert have to prevent this one side view, just to have a bigger overview. Why it is important to have online measurements or PAT in your production. I don't need to say much about the advantages of PAT production. You have the process control, you have cost savings. Beside this, monitoring and control on the process, it's about establishing systems that run autonomously. This is a new way they started. There are several examples in the industry where this is quite advanced. One example is the air separation plants running autonomously. According to my information, Linde have one control room in Germany for a variety of factories spread across the country. So no operators more on the site. You have a truck driver. He picks up some nitrogen or oxygen and gets automatically a certificate printed out after the filling. There are no operators on the site. There are also projects at BASF for autonomous factories and controlled and regulated using PAT measurements. It seems a lot of potential here also for small and medium-sized enterprises. So now the technical challenges. A lot of engineers like technical challenges because they are easier to handle. The first and the most important question is what should be measured and why. You have to dig deep in this with the client or colleagues in the process plant or the laboratory to find out what and why something should be measured. Don't be satisfied with the statement because we measure it in the lab or because that's how it been always be done. This doesn't mean this is the ideal measurement for controlling the process and improving the quality. Quality checks in the lab are not every time adding value. Find a way to get some more information out of a process measurement. For example, ask why a selected point in the pipe or the vessel should be measured. Often it is the case because of the lab sample is taken out of this point. This is fair enough, but doesn't mean this is the optimum point to monitor the process or to control the process. There were even occasion statements in my time at the BASF. We just have a valve there, so we can take out a sample and displace. You put a lot of effort in the installation of a PAT measurement, so please be sure to get the right spot and to get the maximum value out of the information you get from the process. Okay. Of course, it's also important to choose the right sensor device that's working reliable. This is also an important point. It is necessary to test also the devices in the lab or in the pilot plant over a longer period to see the advantage and disadvantage. This saves you a lot of headaches. PAT is also used to have a license to operate the process. So be ensured that the measurement is comply with legal regulations, involve authorities early in the process. Don't buy expensive measurements that are not recognized. I mean emission measurements, etc. Now another slide, it means organizational challenges. Don't underestimate organizational challenges. I like to call it the immune system of the organizations. You have typical phrases to hear like, it's not my job, it's not invented here, the current situation is quite satisfying. Find the right partners, they are eager to work with you in the project and in any levels. Even directly in the plant with the control room operators. Sometimes they are more important than the upper management. You need key leaders in the production plant that helps you to introduce or install the measurements. Talk extensively to the stakeholders. This is also important, which is, I called it expectation management, and train them and inform the colleagues about the situation and how the project is going on. PAT instruments give you more than only the measurement. So that's the point, to find the right partners. Do not underestimate the resistance of your system or of your organization. Find people that are enthusiastic for your project and make them your friends, that you can get a successful project. So now I want to go to the study cases. I have chosen 2 spectroscopical projects we have made in the BASF. The first project you see here, it's a chemical reaction for producing nitrotoluol. And you see at the process conditions, they are very harsh. So you have metal catalysts, you have temperatures about 200 degrees, you have pressures 50 bars, and you have also gas here, hydrogen. You remember my purchase statement: clarify the process, the main task of the measurement. There's a saying, this was very funny. Henry Ford was once said, if I ask my customer what they want, they would say faster horses, not cars. In this context, you see the analytics in the lab is a GC. A logical next step would be to set up an online GC, but that was not done, at least not in this project. The goal was precise, questioned. The detection limit of the DNT and the TDA has to be like 200 ppms. That was one of the main issues. The goal was a real-time measurement without having to put out samples of the process, because DNT and TDA are not very good for the health. And also the process conditions with over 100 degrees was also not so easy to put out some samples. There was an experiment in the laboratory and in the pilot plant with an optical measurement system to see if it's possible to get this low concentrations of 200 ppm. It's an important point, again, to test the ideas you have before you buy everything right away, only to find out it doesn't work. Check the process conditions, if possible, before you make the final decision for measurement. So it takes a long time to make these tests before you think about to install it in the process. Here you can see the picture of a spectrum recorded with a spectrometer. It was found that the wavelength of 500 represents the concentration of the DNT, and it was quite well to see the 200 ppms. At 700 nanometers is a good baseline. Why the baseline? It is important. Consider that you have both gas and solids in the process, so that can interfere with the optical measurement. So it was very important to find it. It was also important to find the right spot in the process to don't have so much interference with the gas and the catalyst and the solids. Later in the project, there was a decision to implement a photometer with the 2 wavelengths. The advantages of this was just required by less maintenance, and the measurement was very robust. So I say you have to find, I call it KISS principle, keep it simple and smart. Always think about the entire lifespan of a measurement and the colleagues who have to perform the maintenance over the lifetime of the PAT system. So what was the key lessons out of this project? You have to define very clearly, what do you want to measure? Don't buy a faster horse. Just see if you have a technology you can take the information out. Keep the eye on the process data, and of course make tests to see if it's a go or no go for the measurement method you have chosen. At least think also about the KISS principle. Make the measurement in the production easy to maintain, and to work with it. Also with people that are not so experienced with PAT. Here I want to talk about spectroscopy measurement for polymerization reaction in a batch process. You see here the process conditions was also a metal catalyst, temperatures about 200 degrees, 10 bar of pressure, and the reaction time depends on the product, 3 or 24 hours. The offline analytics was rheology, IR, spectroscopy, titration, and gas chromatography. So the online conditions of the measurement, they were thinking about how to put this in a process. There was an idea to put it inline, or you can also do it online. Initially, it was done inline, which led to fast measurements and good results. Unfortunately, the window of the probe gets dirty by some reaction products, which causes the measurement to fail because it was not possible to simply stop the process, the batch process, and to take out the probe to clean it. So we decided afterwards to put it online, which is more complex with a bypass, with a pump, but it could lead us to clean the probe during the process. There was also some critical points during the calibration. We talk about the exact time to take out a sample and to compare it to the spectrum we made. It was like this. If you say to the operating people, please take out a sample at 11 o'clock, might be 11:30, it might be 12 o'clock. And if you don't write down the exact time, the spectrum will never match with the sample you analyzed in the lab. We have very intense discussion and supported also to colleagues that they understand we need the recorded time when they put out the sample. I know that the colleagues from Bayer even installed a push button at the sampling point to press it when the sample was taken, just to get this timestamp. So if you do a process, go out and see how the sample for the calibration is done, and also go to the lab and see how the analytics is going. It's very important. During the calibration period, there was also some problems with the process engineers because we had also problems to fit the model with some spectrum we taken by the process, and we find it out that was a change in the raw material they put in. The statement of the colleagues was just, but it's the same specification. For spectrum, that means nothing. So it's important to know if you change something in the system, you have to fit it in your model. Another point, what was the installation? Unfortunately, the optical fibers were damaged twice because the company had no experience with optical fibers, just with cables, and so they damaged the optical fibers. It cost a lot of money and it was a big delay also. So it is important to train and to oversee all the points of the project. I saw at the Acima in this point a retractable probe at Hellma with a sensor gate combination from CNIC. This would be a good solution for this, but unfortunately, this option was not available on the time on the project. Let me summarize about the projects and find and choose the right partners to set up an operation. What it means, first of all, it depends on the circumstances you are. It not mean you have to find a partner in your company. If you're a small company, you can also go out on the market. There are a lot of companies, they have good experience with PAT measurements that can help you at the projects. Find this and try to work with them. You need experience. It sounds hard, but anyway, every project is different, and it's important to have these partners, but it takes times. Oversee the entire planning process. Don't underestimate small things that can have a big impact. And think also about sustainable PAT measurements. Expectation management, the called stakeholders. You have to inform the colleagues and to hold them in time, that they know when there are some problems are occurring, and there will be some problems, that they know what is happening. Don't always buy the fast horse. Make sure the technology you want to use is benefits also in the long term. And one of the most important things is also train and support your colleagues before, during, and after the project, because a lot of work is done after the project when the measurement is installed, to make a model, to make it more stable. Sometimes you have to think about another measurement, and so you lead to a good project and a successful project. Thank you for your attention, and I think we can open right now the question and answer session.
Yeah, big thanks to Dusko. Thank you very much for the awesome talk. So I really enjoyed it, and I'm sure our audience found immense value in our words. I would like to encourage you to also apply as a speaker and share your experience if you want to, because we continuously have different thematic focus and diverse audience here, and it would be great if you would join us as a speaker. So on behalf of Hellma, I'd like to express our sincerest gratitude to Dusko for sharing such an insightful talk with us today. And also, I would like to thank the audience for your participation. So I'm looking forward to see you at one of our next PAT-Forum webinars events. Yeah. Goodbye and see you soon. Thank you very much, Dusko.
Thank you. Bye.